Hello, everyone. Thank you for joining me and thank you for having me. You're welcome to today's class. We are looking at cartography and visualization by Mary Liu Marcellinus, the cartographic lecturer. Cartography is a discipline that involves philosophical and theoretical and the applied basis of the rules for map making and including the study of map communication. Cartography is not all about making maps or drawing maps. It is a broad discipline. It involves the theory, it involves the philosophical thinking, and involves the practice. And one thing that is very paramount for all this, it is communication. The aim of mapping is to communicate geographical information from where it is located, and how it is being located. Conventional signs and symbols. In cartography, there are signs and symbols that are conventional. That is to say, the symbols used in Nigeria here is the same apply in other continents of the world. So that is why it is called conventional, traditional. So in mapping, there are signs and symbols that are conventional, in which one or as a map maker you must abide by it. One of it is the cultural or man-made features. The cultural or man-made features are features that are made by man, such as the roads, the buildings, the streets, anything made by man. It is cultural. And the color used to designate or to use to map or apply on such features are mainly black color. Next is isometric or relief features. Isometric is relief, that is the contour, the height, the elevation of an area of a terrain. And brown it is used to designate such features. Next is hydrographic features, all the water bodies, be it lake, be it river, be it stream, be it pond. The color used for it is blue. The next is vegetation. The conventional sign for it, the conventional color for it is green. If you can remember, for those of you that were in the previous class, I said something about a relief in some region of the world. I made mention that if you are mapping, let's say, the desert area, and to an extent, you are at liberty to use black color to depict the terrain of that area because it is a desert land or desert area. Then the next, let's look at generalization. Note, we cannot just pick data or gather data and start mapping. You must follow the rules. Not everything that you have that you must be placed or placed on the map. So the cartographer must have a thorough understanding of the purpose of the map and the nature of the items being generalized. Generalization is not a task that can be approached casually. In generalization, you must ask yourself, what is the purpose of this map? Don't forget that the main task of mapping is to communicate. So what is the purpose of the map? So based on the purpose of the map, you generalize it based on the purpose of the map. Not every data that you have gathered that will be shown on the map. So the aim of the map must stand out, hence the need for generalization. Method of generalization and the scale. One of the method you need to use is selection. You need to select. For instance, if you are mapping a street network of an area, there is difference between street network and road network. Street network is street within an area, is the street within an area, while road network is the connection on the road that joins one locality, or let's say one state to another, or one local government to another. That is road. So the aim of the map will help you to know how to generalize. One, you have to select what is necessary for that map. Two, simplification. You have to simplify the data so that the map will communicate effectively. Then three, you have to smooth. You have to smoothen it. Then four, grouping. Where there is need, or where there are needs for that, you have to do that. For instance, if based on the scale of the map, if the scale of the map is very small and the area you are mapping, the buildings are much, what you need to do in that aspect, you need to group it. So you group the buildings and it falls as one locality. The next is classification. You need to classify. Then you exaggerate and you displace. What we mean by displace, not locational feature. Yeah, note, I said not locational feature. You can only displace text or numbers on map, not a locational feature. For instance, you are mapping buildings and building A is at point A, because there is no space and you want to displace this maybe to point B, you are misleading the user. So you don't do that. Rather, it is text that is to be displaced, not the locational feature. Note that smaller scale means fewer features. Smaller scale means fewer features. Smaller scale means combining features. Smaller scale means smoother features, and smaller scale means displacing features. Data ordering. In data ordering, as in data measurement, when we say data measurement or data ordering, as in ordering of data hierarchically in their rank. For instance, if you are mapping, you say, okay, I want I'm mapping roads. Maybe you said road trunk A. In that area is only trunk A that is there. That is nominal data. Nominal data, you're just mapping trunk A. Then for ordinal data, that means in that area you have trunk A, you have trunk B, you have trunk C, or what we call federal road, state road, and local road. When you on your map, these three categories of roads are shown. That means that is ordinal data. Order. The word order, ordinal data. Then interval data. For instance, you said from point A to point B. That is the data. That is interval data. Then we have ratio data. Now, this data make use of what we call visual variables. You have to apply visual variables. There are These are the visual variables: the size, the value, the grain or the texture, the color or the hue, the orientation, and the shape. The size, the value, the grain or the texture, the color, the orientation, and the shape. So you have to note this when ordering your data. Then next we see here is map design. Having gotten the data, having known what you are to displace, what you are to eliminate, what you are to select, what you are to exaggerate, what you are to do, having known that, now comes map design. How do you design your map? So map design is the act of effectively communicating spatial information or spatial features. So you have to know how to design it. And where do you sort for the data? You can sort for data by yourself using your handheld GPS. You can use your phone. Your phone has GPS. Or you can use mobile topography to get data. You can use your handheld GPS. You can use ground survey data. You can use existing map. You can use remote sensing, imagery of different size, of different bands to come up with information. So you have to know how to design it, which is very paramount. Now, before I move on, in designing, note that everything must be visual balance. That's what we call visual balance. Your map must have that visual balance, and there must be contrast between the foreground and the background. What I mean by the foreground is the picture they are trying to use to communicate, while the background is other features. For instance, now you are mapping schools in a locality. Schools schools is the foreground. Quite alright. Quite alright. On that map, it's not only schools that be displayed on its note. Roads and other residential buildings, some prominent features will must be on that map. But those other features should not overshadow the main aim of the map, which is school. So the schools must stand out. In doing that, that is foreground, while the other features such as buildings, residential areas, and the likes are the background. So note that. And don't forget the aim of the map. The aim of the map will help you to design map effectively. Then next here we'll look at geovisualization techniques or visualization techniques. It covers data visualization method like choropleth maps, heat maps, dot density maps. This explains how each method can reveal different patterns in the data. Choropleth map. Choropleth map, as we go on, you see it. So these are the techniques you can use for your data visualization. These are the techniques and many more. You can use graph, you can use bar chart, you can use pie chart as um one of the techniques for geo visualization. Then you should also know that we have 2D visualization, which focuses on traditional map making, the normal line, point feature, line feature, area feature that you have. It is visualization, but it's traditional pattern or traditional one, the 2D. The 3D visualization, in this one you will explore. It's all about exploring the model, building visualization. You have in-depth information or in-depth knowledge on the map when your map is in 3D. You have in-depth knowledge or information about the map or about what you have mapped. Then we have spatial analysis in cartography. Spatial analysis, there are many analyses, but the few of it here, which include the spatial interpolation. If you can remember in the last class, I made mention of leveling or terrain. If you are to interpolate the contour lines, how do we arrive at that contour lines? It is the spot height that that you generated or that you have gotten from the field, the spot height. And how do we how do we get it? Using leveling instruments. So you use it to obtain, if you want to know how the terrain or how the area look like when you have spot height of that area, it will give you an insight, more insight on how the area look like. So when you come up from that spot height, you come up with those lines that we call contour lines. That's the interpolation. You have interpolate the values or the point to arrive at such. So interpolation is all about estimating values at unsampled location. That is one of cartographic analysis you can perform. Another analysis there is network. Network is all about connectivity and flows in network. I pray you should know this. And when you are mapping or when you are digitizing or when you are vectorizing, note, if you are starting from up, you must start from up down throughout. You must follow that same pattern. And when you are digitizing or vectorizing, you have to on your snap so that there will be no gap, because if there is breakage as you are vectorizing, the network, when you come for analysis, it will not run, it will not flow because there is disconnection. So you should note that. Then we have geostatistics, which is all about modeling spatial variabilities. Then we have next there we have thematic cartography. Thematic cartography is one of the type of map. At the end of the most of you at your end of your study year will be your product, or the end of your this thing will be thematic. In general, some scholars classify maps into three categories: the general purpose map, the thematic, and the navigational. The general purpose map, which is the topographical map, the administrative map. Then the thematic map or cartography, as you may call it, is, for instance, you say map of schools, map showing roads, climate map, soil map, population map. That is thematic, means theme, single, topical is just a topic. While general purpose map or topographical map is all encompass all the features needed, while in thematic emphasize a single theme or a single topic. So thematic map focus on a specific topics or themes such as population density, climate pattern, or economic activities. Then techniques to visualize data in theme. You can use such a technique such as choropleth map. Choropleth map is all about using or varying a shade or a color to represent data value. For instance, you have you have you want to map, let's say a population. Let's say population. If you're a good mapper, you can use one color to give different information about the population of of a locality or of a state. For instance, what did I mean by that? Let's say you pick red. There are different shade or different grade of red. So a good mapper will use just that color, just red, to depict different population density in a locality. When you do that, you have introduced value into it. Meaning, for instance, an area that is highly density, the red will be high or more thicker. The area that is low in density, the value for that, the red may be, let's say, 70% or 80%. So as you go down, as you break down, that is value, using a color to pass out the information. In doing that, that is chloroplate. The techniques there is chloroplate techniques that you have used. Then we have the proportional symbols. This involves symbols of different sizes to indicate magnitude. Maybe a very prominent um area, the size of the symbol will be bigger. The area that is less prominent or less important, the symbols small. So in doing that, you use the techniques of proportional symbol. Next, you can use techniques such as cartogram. Cartogram is all about distorting area or distance to reflect data. Next, here we have interactive and multimedia cartography. Interactive and multimedia cartography. This is very important. Gone are those days where our maps were only all about static. Our maps have to be interactive. To have more or to make it more effectively, there is need to incorporate or to inculcate multimedia into it. We have multimedia such as audio, videos, animation, and text. With the rise of digital technology, maps has become interactive and multimedia rich. And these are the elements: the audio, the video, the animation, and the text. In doing this, the map will be more communicative. This enhanced map storytelling, when you include these elements, it will enhance map storytelling. For instance, animated maps can show temporal change, such as urban growth over the time. For instance, let's say in this Oyo, in 2000, or let's say 2000 to this is 2025. If you are to show the urban growth, to do it more effectively or more interactive or more communicative, you have to use what? Animation, to show how the town has been over the period. So the animation will help to display it more effectively. That maybe in 2000 to 2010, this is how the extent of Oyo town was. In 2010 to 2020, this is the extent. In 2020 to now, this is the extent. In so doing, one will have more insight into it. So multimedia cartography helps him to communicate the information more effectively. Then in the previous class, I made mention of Mark Ekstrom. Mark Ekstrom and Nko. Mark Ekstrom 1994 says that we should start looking at maps in cubic form, meaning from high level to low level, from private to public, and from low interaction to high interaction. That with this theory, don't forget I made mention of cartography